which lowers blood pressure and can decrease instances of heart attacks. Omega-3 fatty acid consumption can also lower blood concentrations of triglycerides, cut the chances of rheumatoid arthritis, and even reduce some behavioral disorders. Some data even show that the omega-3 intake is associated with poor memory and mood disorders. Interestingly, more and more evidence is emerging to support using omega-3 fatty acids in cases of traumatic brain injury to help with immediate and long-term outcomes for these patients. Essentially, omega-3 fatty acids have the opposite role of omega-6 fatty acids. Because of this, you can see that a balanced intake of omega-6 and omega-3 fatty acids will be needed for optimal health and physical function. Americans tend to have very high omega-6 fatty acids consumption in comparison to omega-3 fatty acids in the diet because of the high content of omega-6s in many of the prepackaged foods and vegetable oils that we eat. In fact, the typical Western diet is reported to be almost 20-to-1 for the omega-6 to the omega-3 ratio. But many experts suggest that the ratio should be more like 2-to-1 or 1-to-1 for optimal health. And this is a real problem because a high ratio is reported to promote things like cardiovascular disease, cancer, and inflammatory and immune diseases. But a higher intake of omega-3 fatty acids seems to have the opposite effect and reduce the likelihood of cardiovascular disease, cancer, and inflammatory disorders. If you can't lower your omega-6 intake, then be sure to reduce the gap in the ratio between eating more omega-3 fatty acids. The balance of the omega-3s in your diet is very important for optimal health. So it's a good idea to attack this from both sides. Decrease the amount of omega-6 fatty acids that you eat and increase the amount of omega-3 fatty acids that you eat. The other type of fat we haven't discussed is trans fat. You may recall that trans fats are often in the media, and legislation in the U.S. to completely ban fats from restaurants has been a big issue. Trans fats are called trans due to the chemical structure of the molecule that surrounds the double bonds between the carbons in the fatty acid chain. Let me explain this. Fatty acids that have a degree of unsaturation will have a double bond between the carbon atoms. This provides a chance for the fatty acids to exist in either a cis form, where hydrogen atoms are on the same side of the carbon chain, or in the trans form, where hydrogen atoms are on opposite sides of the carbon chain. These forms, the cis and the trans, alter the geometric shape of the fat. The transfiguration allows for more stable structure due to the equal distribution of hydrogen molecules on both sides of the double bond. Cis fats with hydrogen atoms on just one side of the carbon atom chain tend to fold upon themselves, while trans fats do not fold up very well. And this makes trans fats able to pack tightly together in the cell membranes and essentially make them rigid. Most naturally occurring fatty acids in foods are in the cis form, and most trans fats are man-made. And trans fats are made in an industrial manufacturing process that adds hydrogen to previously liquid vegetable oil, making it a solid or hard at room temperature. This fat is essentially artificially hydrogenated. This is done to give foods a longer shelf life and may make certain foods taste better. Many restaurants will use partially hydrogenated vegetable oils to deep fry foods because the oil does not need to be changed as frequently as other types of oils. So there is a cost savings for restaurants to consider when they choose the types of oils that they cook with. Many foods contain trans fats, including many baked goods like cookies, fried foods, potato chips, and margarine. A diet high in trans fats may increase your bad LDL cholesterol and decrease your good HDL cholesterol. It may also be associated with your risk of developing heart disease. But some trans fat occurs naturally in food, so it is not entirely avoidable. Now, you may wonder just how much of each type of fat you should eat. Well, opinions vary, but the American Heart Association recommends that for good health, the majority of fats that you eat should be monounsaturated or polyunsaturated, rather than saturated fats and trans fats. Others recommend eating about 1/3 of each type of fat: saturated fat, monounsaturated fat, and polyunsaturated fats that include a balance of omega-6 and omega-3 fatty acids. I like to focus on eating high-quality sources of fat like avocados, nuts, seeds, olive oil, and omega-3 fatty acids from fish and fish oil. Then I just let the rest of my fat take care of itself because it's already in many of the animal products and occasional treats that I have. This has worked well to balance my fat intake to roughly equal parts of mono, poly, and saturated fat intake. So now you understand that there are different types of fats that we can consume and different ways in which we can store fat in the body or use it for energy. And fat is an enormous supply of fuel for us to tap into, and understanding fat use will clearly help to improve body composition. The 2010 Dietary Guidelines for Americans recommends fat intake to be between 20 and 35% of your total calorie intake, and recommends that saturated fat make up no more than 10% of these calories. They also recommend replacing solid fats with oils when possible, and limiting foods with trans fats or hydrogenated oils as much as possible. The guidelines also recommend eating less than 300 milligrams of dietary cholesterol per day. According to the U.S. Department of Agriculture, one large egg has about 186 milligrams of cholesterol, all of which is found in the yolk. So 2 eggs would put you over the recommended limit. But as we've discussed, this relationship between cholesterol and saturated fat in the diet may not correlate with cholesterol in your blood. Also, many vegetable oils are very high in omega-6 fatty acids, so that could be exactly the wrong recommendation to give to people. So, clearly these fat-related scientific topics continue to be hotly debated as of 2015. No matter how you cut it, fat is the most energy-dense macronutrient that we eat because 1 gram of fat yields 9 calories. And many people don't need to seek out additional fat to eat when considering total fat eaten per day. That's because fat is usually in many of the foods you eat normally. However, research is now showing that it may be useful to make a real effort to eat more high-quality fats in your diet, like nuts, seeds, avocados, and fish. These foods, as you know, provide a nice variety of saturated, monounsaturated, and polyunsaturated fats. And because fat helps you feel full, these foods can be used to help reduce the total amount of calories that you consume in a day. One question that you may have now is, how do I actually burn fat as a fuel? How do I use my stored fat to provide energy and ultimately improve my body composition? Well, as I mentioned earlier, fat provides the most abundant source of energy that we have. It fuels your body at rest and during light to moderate intensity activity. And during this type of exercise, a muscle's main source of fat supply is your fat, or your adipose tissue. Muscles can also rely upon fat that is stored inside of the muscle called intramuscular triglycerides, or IMTG. The amount of intramuscular triglycerides used during exercise or activity will vary with your fitness level. With the more fit you are, the more fat you'll use. This is a great adaptation to exercise, actually. With fat stored in your muscle, it is already located where it needs to be in order to be used as energy. The amount of intramuscular triglycerides will also vary with the intensity and the duration of exercise, where longer and slower activity will rely more upon fat use than short and fast activity. The trick is for your body to get the fat from your fat cells into the blood and then into your muscles in order to be burned or oxidized for energy in the mitochondria of your cells. To do this, fats enter something called the carnitine fatty acid transport system. This system works as a gatekeeper to allow fat into the cell's mitochondria. But fat is not able to enter the mitochondria effectively when levels of glucose are high because another molecule called malonyl-CoA shuts down the carnitine transport system. This means that after a high carbohydrate meal, for example, a muffin, you literally impair the ability to transport fat into your cell's mitochondria to be used as energy. Likewise, some hormone changes occur with high carbohydrate intake that can also work against you being able to burn fat. So just be aware of what you eat and when you eat it. It can impact your body composition and performance dramatically. Anyway, once the free fatty acids released from the stored triglyceride are inside the mitochondria, these fatty acids are broken down to provide energy during a process called beta oxidation, which just means fat is burned as a fuel. What all of this boils down to is that to use fat as a fuel during exercise, your body needs to be able to break down stored triglycerides into free fatty acids to make ATP for energy. The intensity of the exercise will determine if fat will be used during exercise. The more intense the exercise, the less your body will be able to utilize the fat stores and vice versa. As mentioned already, fat oxidation or burning is regulated in part by how much glucose you have in your blood. So eating lots of carbohydrate will increase blood glucose and decrease the breakdown of stored body fat, which is called lipolysis, and fat's use or oxidation for energy. But fat oxidation is enhanced by exercise training. And this occurs because exercise training can increase the number of mitochondria you have, as well as the capillary density. The increase in mitochondria will help the body process the fat at a higher volume, and an increase in capillary density will help increase the blood flow and oxygen delivery to the exercising muscle, which is required to burn fat. Exercise training will also increase the activity of the carnitine fatty acid transport system that essentially allows more fat to enter the increased number of mitochondria that you have from exercising. Interestingly, some supplements may also work through this transport system to help burn fat. We will talk more about this in an upcoming lecture. So, as you probably expected, exercise does help to burn more fat. But of course, it depends on the intensity and the duration of exercise, as well as that overall mix of foods that you have recently eaten. Another interesting aspect of fat burning is the difference we see between men and women. Early studies of sex differences in fuel use during exercise were conducted during the late 1970s and early 1980s. Men and women were asked to run between 65 and 70% of their maximum intensity. And repeatedly, fat use was not shown to be different between men and women when running at a set percent of their maximum. But in follow-up work, another study tracked the number of miles that the men and women ran per week, their years of exercise training, and their relative ability to use oxygen